Good morning, dear students. Welcome to your maths class. Yes, in the last class you had learned 7 definitions which were given by Euclid. And based on his definitions, Euclid assumed certain properties which are not to be proved. These assumptions are actually self-evident true statements, and he divided these statements as axioms and postulates. And also you know that axioms can be used in any other branch of mathematics, and postulates are particular to geometry only. And in today's class we are going to study some of Euclid's axioms. Okay, let us look on to it. Children, observe here. In these pictures you are watching, some geometrical patterns are there, isn't it? Now observe the first one. How many parts are there? Yes, 4 parts. In the second picture, here also there are 4 parts are there, and in the third picture also 4 parts are there. So, can we say the number of parts in the first picture is equal to number of parts in the second picture? Yes, again like that, the number of parts in the second picture is equal to number of parts in the third picture. Yes, this is also equal, isn't it? Now, think and answer me. Can we say the number of parts in the first picture is equal to number of parts in the third picture? Yes, we can, isn't it? So, how will you say that these two pictures are equal? Yes, your intuition says that it is true and you agree with this, isn't it? Okay, here, let me give another example for you. Here activities for you. All of you pass this video and go and get your mathematics notes, one ruler, one compass and a sharp-minded pencil. Okay? Are you ready now? Open the last page of your notebook now. In that, draw a line of length 6 centimeter. Okay? Let me also draw. Here I am going to draw a line of length 6 centimeter and name it as AB. And again draw another length of same measurement, that is 6 centimeter. Now can we say the line AB is equal to CD? Yes, we can. Again draw another line of length 6 centimeter. Okay, and name it as EF. Now can we say the line CD is equal to EF? Yes, the line CD is equal to EF. Now you observe the line AB is equal to CD and the CD is equal to EF. Here CD is common to both the lines AB and EF, isn't it? So we can say that the line AB is also equal to the line EF, isn't it? Because these two lines are equal to the same line CD. Here, yes, we can say the line AB is equal to the line EF. Yes, from above these two examples, what can we conclude? Yes, things which are equal to the same things are equal to one another. Yes, here these two are the things which are equal to the same thing, CD. So these two lines are equal. This is what your axiom 1 says. Axiom 1 says things which are equal to the same thing are equal to one another. I hope you understood axiom 1. Shall we move on to the second axiom? Now, in the picture, I have taken 4 color pencils. Again, I am going to take another set of color pencils with same number of pencils as previous. Now, here, I am going to add one pencil to the first set and again same number of pencil, that is one pencil to the second set. Children, observe here. I'm adding equal number of pencils to each set, no? Then tell me now, how many number of pencils are there in the new set that is formed? Yes, good. Now each set that is formed newly contains 5 pencils and they also become equal. So, can you give one statement to this? Yes, if equals are added to equals, then the wholes are equal. Again, here, I am going to give another example to you. And here is another activity for you. Yes. Now, draw two lines of length 6 centimeter. Here, I am going to draw a line 6 centimeter and name it as AB. Again, line of length 6 centimeter and name it as CD. And draw another two lines of length 3 centimeter each. Again, I am going to take a line EF and GH, that is also 3 centimeters. Now observe, these two lines AB and CD are equal and these two lines EF and GH are equal to each other. And now I am going to add this EF to the line AB and GH to the line CD. Also here I am going to add these two lines. Yes. Now I am going to add the line EF to the line AB and the line GH to the line CD. Yes, here the two new lines formed, that is AF and GH. Yes, whether these two lines are equal? Yes, the two newly formed lines are also equal. So now can we say if equals are added to equals, then the wholes are equal. Yes, this is your axiom 2. If equals are added to equals, then the wholes are equal. Now again, I am going to take off these two lines that previously I had added to this AB and CD, that is this EF and GH. Then can you measure the length of the remaining part of line? Yes, here I am going to take off this line AB from the line EF and again the CD from the line CH. Okay, yes. They are also 6 centimeters and they are equal. What we did here? Yes, we removed equals from the equals. Yes, the remainders become equal. So, can we conclude if equals are subtracted from equals, then the remainders are equal? Yes, this is your axiom 3. If equals are subtracted from equals, then the remainders are equal. I hope you understood. Children, here is another activity for you. Now construct two circles of radius 3 centimeter each. Let me also do. Yes. I'm going to take the radius as 3 centimeter here. I did. But you have to use your compass to construct circle. I hope you all know how to construct a circle of given radius. Yes. Here I am again going to draw a circle of radius 3 centimeter. Now I constructed two circles of same radius, isn't it? Now cut these two circles and then superimpose it to one another. Yes. Now I am going to superimpose the circle 2 onto the circle A like this. What I had done? Yes. I superimposed the circle 2 on to the circle 1, isn't it? Yes, I did. Now observe children. Where is circle 1? Yes, circle 1 is now superimposed with circle 2, isn't it? And we can't see circle 1 now. Tell me now. Tell me how those two circles superimposed. Yes, they are identical. They are going to coincide with each other. Now can we say things which coincide with one another are equal to one another? Yes. This is your axiom 4. That is, things which are coincide with one another are equal to one another. Okay. Shall we move on to our next axiom, that is axiom 5. Here I am taking an apple and now I am going to cut this apple into its parts. Now you compare its parts with the whole apple. Yes, the whole apple is always greater than its parts, or vice versa, its parts are always smaller than the whole apple. So we can conclude that the whole is always greater than its parts. Okay, this is your axiom 5. Let us move to our next axiom. Here I am going to take two glasses in that each glass the same quantity of milk. Again I am going to take another two glasses and in that each glass the same quantity of milk that I had taken in the previous. Now I am going to pour these two glasses of milk in the glasses that I had taken in the previous. Now what happens? Yes, the milk in these glasses doubles. Now compare these two glasses which contains milk. Is they are equal? Yes, they are equal. Now can we say things which are double of the same things are equal to one another? Yes, this is your axiom 6. Okay, shall we move to our next axiom, that is last axiom in your syllabus? Yes, children. Here I had taken two bananas of same size and now I am going to cut these bananas into its parts. Then measure these two parts. Whether these two parts are equal? Yes, they are equal. So can we conclude things are halves of the same things are equal to one another? Yes, this is your axiom 7. Things which are halves of the same things are equal to one another. I think you have understood, children. In today's class, this much is enough. And the next class, you are going to know some postulates of Euclid. Okay? Thank you, children.